Okay, just brief context. We are ex-OpenSearch folks, kind of, I guess, the OGs in search. We built what is now known as OpenSearch many years ago, and then we left Amazon and have recently reconnected to solve some problems that we have seen in OpenSearch for many years. So the first thing we've done is we rewrote Lucene from, oh, sorry. I didn't realize I have to do this. Okay. Yeah, so the first thing we did was to rewrite Lucene, which we've rewritten from the ground up, every line of code. That's been a beast, if any of you have dealt with Lucene before, and getting all of the query coverage and all the aggregations and all the APIs and all that stuff. But we've rewritten it in Rust. We have a completely different architecture, a different segment architecture. We don't have a concept of shards, so it's, in theory, infinitely scalable. And so the motivation to rewrite Lucene was that, OpenSearch and the ELK stack in general is used for use cases in which it really wasn't built for originally. So the original thrust of Lucene was really around e-commerce search, and it still maintains a lot of that DNA. If any of you have dealt with the Lucene code, it's very, very e-commerce focused. And so we just thought that OpenSearch needed a rewrite. And obviously you can't rewrite 3 million lines of code, so we thought we'd rewrite the core. So we have been very focused on the observability and security use cases. So what we did was to rewrite Lucene. Was not really rewriting Lucene, writing a new engine that has a Lucene API. So when OpenSearch talks to the engine, it thinks it's talking to Lucene. And then we've had to go in and kind of hijack all the messaging protocols in OpenSearch to like redirect traffic. If it's a request that we think should go to our engine, we route it to our engine. If it's something we think should go to Lucene or either go to the vector engine, then we sort of reroute appropriately. But rewriting Lucene has done several things. One, we're like way more cost, we're like running 10x, cheaper, I guess, than OpenSearch, like the standard OpenSearch service. So people who are doing like really big workloads, they get a big cost savings. And then one of the things that we've done is to add Prometheus and metrics native to the engine, which means that OpenSearch, at least our version of OpenSearch, runs Prometheus queries natively, so you don't have to run like Prometheus and OpenSearch separately. And it also means that you support Grafana natively. So now, with Infino, you can choose OpenSearch dashboard, you can choose Kibana, you can choose Grafana, and we have other things. And so what we've done is to implement this, we ended up, we have a different segment architecture where, because it's an observability use case, the index is append only, which is the typical use case. It's quite different from how Lucene normally works. And again, Lucene is built for very fast numeric updates, which happen in e-commerce. Observability engines aren't really built like that. And we implicitly shard on time. And so everything in observability is chronologically ordered, meaning the request, the data, everything's timestamped. So it's kind of a very different use case, say, from fast product updates. And so because we've organized it based on time, for a given query, we usually have to search a lot less data than Lucene would. To extend the index, we don't have to do index rebuilds. There's no concept of index management with our engine. There's no sharding. There's no, like all of the cluster management stuff in Open, it just goes away. It's all the backend store is no longer disk, it's cloud native, so we assume there's an object store on the backend, which means you make different I/O calls from what Lucene does. So we don't have to like write to disk and then ship that, if any of you know the internals of how Lucene works. You don't have to write to disk and then ship that off to object store, we just write native over the wire. So that also helps tremendously. But the big thing is to be able to, once you create these segments, which are basically time, you can think of as time sharding. It's not really sharding, but you can think of it as time sharding. Then on a given segment, every segment is completely independent. So you don't have the same kind of global coordination you do in Lucene between all the segments and the shards. And so on a given segment, you can decide whatever you want sits there. So we've rewritten Prometheus from scratch. And in Rust, in the engine, native next to logs. So in the inverted index, you have like many different data types, which are automatically detected and then kind of formed into the inverted index. But the net of it is that you can issue a single query to search both logs, metrics, traces, whatever. Like today, if you're trying to debug in OpenSearch or any of these stacks, right? Typically, you'll have like Prometheus for APM or something like that, Datadog or whatever. And then a lot of times, a lot of people use OpenSearch or ELK for logs. But the SREs or the ops folks are constantly switching back and forth between tools. Or even in OpenSearch, if you're doing metrics, when you switch between the panels, it's almost like a different product, right? And so we wanted to kind of fix that experience. So now you can just issue a single query in Query DSL or PPL or DQL or whatever, and you can actually grab Prometheus metrics and like OpenSearch logs together in the same response, and we formatted it so it kind of all looks like Query DSL. But the key is really the technical innovation is really how we actually segment the data in the index, and then how you distribute those segments over distributed infrastructure. And that enables you to then put lots of different data types in the same segment next to each other around the same time, in the same location. You all search them together. So, but the net of it is that we've been able to basically add Grafana native to OpenSearch. So when you run our version of OpenSearch, you can either choose Grafana, you can choose OpenSearch Dashboard or Kibana, or we have this other thing called dynamic dashboards, which is Streamlit driven, which is all natural language. So as you're typing, we're drawing real-time dashboards as you're typing questions. So it's basically like it enables a full kind of automation layer on top of OpenSearch once the underlying engine can support it. So I don't know, that's kind of what we're working on. We're still kind of in development. We've just deployed with a couple customers. We just got back together like a year ago, maybe after 10 years. Asif went on to do great things at Google and LinkedIn, and I did a few other things, and Vinay did a few other things, so we're back together now. But that's the story of Prometheus. We're pretty excited because I think, it does allow you to do queries that are just not answerable today by any observability tool. For example, very simple query I always highlight is, what were the 500 errors when the CPU spike happened yesterday? Like that very simple query, there's no tool in the world today that answers that query in one shot, right? And it's a very common query that certainly I would have asked my VP of engineering whenever there was an outage. And like, how many customers were affected? Well, no one can really answer that question very easily today too. So we're just trying to take a little bit of a leap forward in the core engine in OpenSearch. That's that. And then you want to add anything to that? Sorry, I'm just going to yapping.
No, I think that's kind of the core engine, and I think on top of that, what we're doing is we're trying to essentially build a automation layer so that you can, you just point us to your GitHub repo, and we will automatically instrument the code with OTel for you. And we're actually internally using fine-tuned models to be able to kind of create multiple agents for logs and metrics instrumentation. So basically, we're looking through your code, and we're able to then glean what are the most important business and system metrics that you should have. So the idea is that, we've been talking with customers and realizing that sometimes to add a metric to your existing pipeline can take weeks of work. But I think if you can, use our automation layer, point us to your code, we'll do that work for you. We'll send the data directly to Infino, index it as logs and metrics, and as Akechi said, that enables these native joins. But then we can also programmatically kind of create panels in your existing dashboards, be it Grafana or OpenSearch dashboard. We connect to that, through the APIs available to us. And on top of that, we've kind of built our own, what we call dynamic dashboards, but it's essentially a natural language interface where you can actually, query these joins, but also get back visual responses as dashboard, static or dynamic, and that's where you can actually start doing more effective debugging. So all of this is possible because we have a core indexing layer that we control, and we can actually store all types of events, be it logs or metrics. But over time, we think that we can actually put more customer-centric events in that index, and then that just makes that plus natural language just makes debugging a lot more simpler and powerful. So that's kind of the it's still work in progress. I think we're working with a couple of kind of design partners to test this out. If anybody is interested in learning more, we'd love to kind of partner with you. I think we're onto something that's next gen in terms of where I think search needs to go to support observability use cases. But yeah, any questions?
I would actually also, without OpenSearch, this gets very difficult. Like all of the models need to have seen queries like Elastic or OpenSearch queries to be able to translate those. So if we had done something that was not out in the open, like an open source, like if we hadn't used OpenSearch, I think this would be much more difficult. So I think OpenSearch and all the features of OpenSearch, from like security to alerts, like all of those just work out of the box. And we really just focused on solving like cost, scale, getting metrics into the core, and all the things that people have like been asking for in OpenSearch like for years, which we've heard just because we've been involved in the project for many years. So yeah, I think that's, ideally, hopefully we'll be able to allow ops to basically push one button. Or like a developer who's like, our goal is like a developer who's working on a service that doesn't have good SRE support or ops support can instantly get full observability without worrying about it. An exec that wants to find out what's happening in an incident doesn't have to bug their SRE or VP of engineering. They can go create their own dashboard and find out what's happening. And so hopefully just make it like a lot simpler, cheaper, smarter kind of thing. Anyway, that's, yeah.
Anything you could share about re-implementing Lucene in Rust?
Oh my God.
Was good, I'll learn eventually. So I've sort of been waiting. I've seen like someone did a C version of Lucene that did 80% and missed out on some big parts. Rust being used in the Linux kernel. Anything you can share about what that experience was like? I mean, do you think more people will start doing this, or are you like, oh, such a nightmare? Do not go down this path.
I wouldn't discourage anyone. I would say that this is the 4th time we're rewriting the engine in OpenSearch, so we have some experience. Okay, so that helps. I would say this company is not possible 2 years ago. Like, without GPT, this just doesn't happen in a time frame and with an amount of money that makes sense, right? So, I think what's challenging about Lucene, it's very easy to get to I built a search engine checkbox. It's very difficult to get all the nuances of the query languages because it's not documented. How do aggregations actually work, right? And actually Lucene is a pretty, you don't realize until you get in there, it's a pretty optimized piece of software. It's actually hard to beat Lucene, on performance.
Right.
So all the data structures, it uses very modern data structures, even though everyone says it's in Java and it's slow. It isn't that slow. Okay?
It's like C code.
Yeah, it's pretty optimized. So beating it performance-wise, we've had to just take a completely different architecture to the index. It's not a traditional search index the way we've built it. What I can say about the actual coding in Rust is nirvana. It's a smart compiler. When you combine that with code gen tools, I don't know. And in Rust the code is a lot more compact. So I just give you an example. If I have to fix a bug in the Rust portion of our OpenSearch, I grab a coffee, I sit down, do my normal thing. If I have to modify the OpenSearch code, I get a good night's sleep, right? I think about it all night, and then I wake up and I'm like, okay, all right, here we go. And then I dive in, and it's just a completely different world. I think more people will rewrite the engine, but getting all of the coverage, if you're trying to replace Lucene, the coverage is a lot of work.
Were you able to run your code against the Lucene test cases?
Yeah, we've run against benchmarks. We're probably an order of magnitude, at least today, order of magnitude more efficient than Lucene.
I think one takeaway, at least for me, is having kind of done this multiple times, I think our thesis is that we need more special purpose search engines for different domains. I think 25 years, Lucene has kind of ridden an amazing wave being a general purpose search engine. It's worked, and it continues to work great. But I think if you really want to optimize for particular use cases, for example, we know that the data that's coming in from logs is append only. You can do a lot with just that property, right? And I think that's the That's the kind of thing that you can do a lot better. Having worked at Amazon and knowing what product search looks like and how you can optimize that, having worked at LinkedIn and knowing what graph search looks like, and moved away from Lucene to building our own general purpose engine. I think over the years we've all learned in this team that I think that if you really care about performance and scale, you have to kind of optimize for the particular corpus.
Yeah.
Okay.